Hello everyone and welcome back to the channel. In this video we are going to talk about implementation of linked list. So let's get started. So in the last video I mentioned that interviews are real life applications of linked list. Well, that's obviously wrong. I just mentioned it because it came to my mind, that linked lists are a very hot topic when it comes to interviewers. And I even said that I even asked those questions. But they're really not a real life application of linked list. One real life application of linked list is also considered in the field of mathematics, which I missed yesterday. And that is to represent polynomials as well. They are used to represent polynomials as well. They are used to represent graphs as well. Like in future videos when we talk about graphs, we'll see how underlying linked list can help us to represent a graph. Obviously languages like Java or C++ with STL, they have a lot of abstractions on top of it. But if you have to implement something like this in C, linked lists become a basic building block, just like how ABC becomes the basic building blocks of the words and sentences. We're going to talk about more, but for today we're going to talk about the implementation of linked list. And we're going to try to understand it in such a way that the language in which we are going to implement it does not become a bottleneck for us. So for this video, I'm planning that I'll implement linked list in C++ and Java. I'm probably going to try implementation of linked list using classes in C++ and not by the conventional ways in which you'll find on Geeks for Geeks, like using struct and so on. I'm trying to have it in a class way. And then in the future videos, we are going to solve some interesting problems also using linked list. So now let's talk about the implementation. So here we have a simple structure which we are going to implement using linked list. So let's try. Let's first try to understand what all components our linked list is going to have. Okay, so these let's have some terminologies in our hand. So this box that I have here, I would like to call this box a node. This is the terminology I'm going to use. So I'll say node, right? What all things does the node have? What are all the things that a node has? A node has a data element, as we can see. Now this can be a name, a string, an integer, a double value, or some custom object as well. So for this example, let's consider that it has an integer. It has an integer data here. So we can say that it has a data component. So rather let's write it has a data component itself. So it has a data component. Number 2, it also stores information about the next element, right? So it points to the next element of the list. Now specifically we're talking about singly linked list here, so there is only one link between any two elements, right? So between two consecutive elements, right? So so now we have a next link as well, right? So now two things in my node, right? And this entire component that I have, I'll call this my linked list, right? So one thing I have node. Now what is my linked list? My linked list is a linear collection of all the nodes, right? Where the starting node is called as head. So this node in this example, this is called head, right? So this is called the head, and this head stores reference to the next element, and every other element stores reference to the next element. And the last one, you may ask what the last one points to, Shubham. So last one does not point to anything, simple. So it's the equivalent of nothing in every language. So some language like C++ may call it as null pointer, or C may call it as null, null. Java would have small null, Python would have none, so on, like that. Okay, so this is the basic building block of linked list. We have a node, and the collection of these nodes which are interlinked is called a linked list, right? So this is the basic information needed to write code for linked list. If you have understood this properly, we'll dive into the implementation section, and then there you may be able to understand it in a better way as well. So first I'm going to implement this using C++, as I said, using classes, and then we are going to implement the same linked list in Java as well. So just to tell you that this is not a language dependent thing, it's language agnostic. So you should understand the basic concept of a linked list. If you're able to understand how does it work, then every question of linked list is a simple. Now most of the tough questions will also involve just a trick or something. Once you understand the basic structure, you can do a lot more than solving challenging problems. So with this said, let's move on to the next section and write some code. Alright, so let's start the implementation. So let's first start writing some boilerplate code. So which is, I'll just include IOStream just in case if you need to print something to the console. I'll use using namespace std because I don't want to write stdc out every time. And then every C++ program needs a main function. We'll give it that, and then let's talk now. So what did we talk about in the previous section? A linked list is consists of nodes, right? And a node has two things. It has a data component and it has a reference to. So basically it has a reference to it. In C++ it's represented as a pointer. So it has a reference to its next counterpart, which is next, right? And a linked list has a head, right? That's what we spoke. So it has a head. That's all. And now we can add some questions. So these are the two basic things that we need for linked list, right? So let's make a class for node. So class node, right? So in this case we're going to store integers. So I'll say, let's make this private int data, and we have node star next. It's a good idea to have private data members because, well, it's a good practice. You should have getters and setters for them if you want to mutate any data. More on that we can cover sometime later in another video why this is a good practice, but for now we'll just stick to it. Let's make a constructor data. Alright, so we'll make a constructor where we'll make a parameterized constructor. We'll have node data, in which this data is equal to data and this next is equal to null pointer, right? So far so good. Let's define some more methods as well. So we'll define, let's say, void set data, int get data, and then we have, for this node we have void set next, which will take a node. Let's call it this as node itself, and then it'll take, and then it can return as well. So node star get next, right? That's all. So for this node we have the things as we planned. We have a data component. So let me just, we have a data component. As we said, we have a next link reference, right? This is a constructor. I'm not really much sure about using a destructor here, so I'll skip that part. But obviously if you are a code which goes into production will not be like this. This is just for demonstration purpose. So we have getters and setters. Let's define these getters and setters, and then we'll jump to defining the linked list class. So now what's the return? Void node scope set data. this is the scope resolution operator. I'm telling that I'm defining the function set data inside present inside node here. Let's see, set data. So set data takes an int data as well, right? So this data is equal to data, that's all. Then we have int get data as well, which returns this data simply. Then we have, let's keep the setters at the same place. We have void node set next, right? And set next will take a pointer to the next element and will do this dot next is equal to, let's call it node itself. This dot next is equal to node. Okay, and then we have last but not the least, node get next, return this next. All right, this is done. So far we have a linked list class node, and we have some getters and setters, that's all. Now let's define a class linked list. All right, now this class will have only one thing, a head, right? So we'll say node star head. It's important to declare a constructor and initialize everything, because if you don't initialize, you'll get a segmentation fault, because there's no memory allocated, right? So you cannot, and linked list works entirely on memory allocation, so it will not work. So write constructors appropriately. Public linked list, this is one is a non-parameterized, no args constructor. Here we'll do head is equal to pointer. By default we don't have anything in the linked list, right? And let's add a function which will be similar to a function that we have vector, which we have in vector, which is push back, right? Which will take the linked list and add an element at the end of the linked list, right? We'll talk about all this logic, but before that, just let's take a couple of minutes and just understand what we have done here till now. So we spoke about a linked list has two things, a node and the class linked list itself, right? And a linked list is collection of nodes, and the first node we just keep a reference to it, that's the head node, because we only need to keep a reference to this node because all the other nodes keep a reference to their corresponding next node, right? So there we define the node class, private data members data, and the next reference link, getters and setters, so on. So far so good, simple. Let's define a function which will do pushback. Let's add a comment, inserts a data element at the end of the linked list. Right, now focus, I need your focus here. Void pushback, we'll take data, right? Let's implement this. So now we have void linked list pushback in data. Well, for a moment, let's just let's try to compile this code and see if we get any compilation errors. We do. So it says incomplete type data. We missed the type data here. It is integer. What all does it say? Semicolon at the end of member declaration. We have it. Let's see. Node declaration matches int node get next. Do we not get next? Okay. Okay. So this should be node star get next. Right. No more errors. I hope not. Let's just run this. Okay, fine. Nothing, because we haven't done anything in the main function, right? So no more compile errors for now. Let's see. Let's implement this method. Now pushback, right? Now let's see. I need your focus here, okay? I need you to visualize now. So there could be two scenarios. we don't have anything in the linked list, and we already have some elements in the linked list, one or more than one, right? Let's see. So suppose we don't have anything. What happens in that case? Here I'll show linked list, or I'll call my linked list, right? I just made it. I just wrote this line. What does this line do? It calls the default constructor in which we have head is equal to null pointer. So head is null right now. So let's do one thing. Let's say if, so we have two cases now. This is the first case. So if my head is null, we don't have anything in the linked list, what we do is we make head as the first node, right? We make the head as first node and its next points to null or null PTR, basically this, right? What I'm going to do is I'm going to do head is equal to new node of data, right? So what does this constructor do? It basically takes the data, it makes a new node, initializes the data and initializes the next as null, right? Then we return from here. Otherwise, if we already have elements, we need to go to the endmost node and then append our node to it, right? So let's see, let's do it. Node reference to current node is equal to, we'll start from head, right? Then while current node not equal to null, and so we start from the current node, and from this node we go to the end node, right? To go to the end node, we'll go to the node whose next is null, right? So if current node is not equal to null and current node get next is also null, not null, this is just a sanity check. Current node should not reach here because head is never null, but I'm giving it, and it should be null PTR, not null. What do? We make current node is equal to current node dot get next. Again, try to understand this line. I'll just comment out, right? So suppose we have 1 2 3 4, so our head points to 1 right now, right? So head is at 1, so our current node at this point will be head, and so while let's dry run this loop, right? So if current node is not null, no, current node dot get next is 2, so now head points to, so current node points to 2 now, the node which has 2 as its value. I'll better write it as node of 2, right? Again, is the current node null? No. Is the current node dot get next null? No. So we current node will then point to its next, which will be node of 3. Now is the current node null? No. Current node dot get next is null? No, because 4 we have. So current node will then point to node of 4. Is current node null? No. Is current node next null? Yes. So this loop will terminate and we'll be at this node of 4, right? So now we have to initialize, add a new node at the end of this list, right? So we do current node dot set next, right? We just need to set next, right? New node of data. Make a new node, set the next node of this current node. We set this as next node, and this new node in the constructor itself we said that the next should be null pointer, right? So it's just a game of references. You just change reference from here to there and your linked list will start pointing somewhere else. That's all, right? So this is, I think this should work. So now one important function that we should implement is void print let's call it print list, right? And let's implement it. Void linked list print list. So let's see, node star current node is equal to head. Now in order to print the list, okay, in order to print the list, I was looking a way to comment properly, but never mind, I don't know the shortcut here in VS Code. So suppose we have 1, 2, 3 and 4, right? So here, instead of doing the same thing that I did above, we'll do something very similar but just a little bit of change. So let's say we are iterating our list, and I'll say current node is head. So current node is basically node of 1. Current node null? No, let's go to current node dot next. So now my current node points to node of 2. I'll print the data and I'll go to current node next. I'll print the data only if my current node is not null. Current node, and then I'll go to the next node, so node 4. Now current node is not null, so I print it. Now I go to current node next of 4, which is null in this case, right? Then I'll not print anything, and then my loop terminates. So this is the simple logic I'm going to put in the loop itself. While current node not equal to null pointer null ptr, we do current node to current is equal to current node get next, right? And we're gonna do current node get data. Give nice little formatting and here, right? Let's see. Let's just first check a compilation works here till here or not. Alright, we have done things properly. Hopefully this will work. Let's see. My linked list dot pushback 1, and I'll copy this line 2, 10, 3, 4, 5. My linked list dot print list. And here we are, 1, 2, 10, 3, 4, 5. So that's how, guys, that's how we implement linked list in C++. I hope this made sense. If it did not, I would recommend you rewind this video, watch it slowly, and I'm pretty sure it's not that a big deal. It's very simple code. I did not go with a traditional way of using struct and everything. I just wanted to go in a sort of an object oriented way so that you guys can visualize OOP as well. So here it is, linked list basic implementation in C++. In the coming video, we are going to solve a lot of good problems on this, maybe on Lead Code or Geeks for Geeks. But for now, the linked list implementation in C++ ends here. Hold on to the next section for checking the implementation in Java. So now let's talk about implementing the same linked list in Java as well. So as talked before, we will have a node which will have a data element which is integer in our case, and we'll have a next reference as well, right? Then we'll have our own linked list class, which will have a head, right? And in this linked list class, we'll have a push method which will add element to the end, to the end of the linked list, and we'll also have a print list method which will print the elements of the linked list, right? So let's define our class node. Okay, so we have our, let's keep them as private. Again, same good practice, private in data, private node next, I'll generate getters and setters for them. Alright, getters and setters generated. Let's generate a constructor as well. We'll take data and we'll define this dot next is null. Same as C++, right guys? We have node defined already. Now let's define our public class linked list. The name of the file is linked list, so that's why it has a private node head. Okay, then we have some public methods, which is public void push int data, and again the same scenario. So if our head is null, for the explanation you can take a look at this C++ video. Here I'm assuming that you have understood the idea, and I'm explaining like a little bit faster than how I explained in C++, but again I'll try to be slow and not just run away. So if head is null, this is the case in which we are trying to insert for the first time. What we do is we define head as a node itself, the next as null, so here, and we return from here, right? Otherwise we have to traverse the list and go till the end, right? Again I'll write the one second. Okay, and let's again take an example. So if I have 1 2 3 4, right? So now what we do is, one is suppose if we are at 1, so current node is 1. We check if the next is not null, then we go to another node, next node, which is node of 2, and again we check if the next is not null, we go to another next node, node of 3. Again we check if the current node is the next of current node is null or not. So at 3 the next is 4, which is not null, so we go to 4, node of 4. Okay, and then now we reach at 4 and we ask, is the next of 4 null? And it says yes. So what we do is current node dot next is equal to new node of the data that's given to us, right? So let's implement this. So while let's take a variable node current node, we started head, we have to iterate all the way back to the end, while current node is not equal to null, current node dot next, right? Current node dot get next not equal to null. We go current node is equal to current node dot get next. Okay, we'll terminate, and then current node dot next dot set next new node new node of data that's given to us. That's all. That's all the implementation for push, right? And then we'll implement our print function as well. So public void print list. All right, so here, so let's again take an example. So suppose we have 1 2 3 4. Is my current node, let's start with current node initialized to the head, which will be in this case be node of 1. Is my current node null? No, right? I can print it. Print 1 in this case. Move to the next without checking if the next is null or not, because we do this check beforehand itself. The current node is null, we just don't go ahead and we just print the data. That's what we do. So if current node now will point to, will be node of 2 now, so we print 2. It's not null. Again it goes to the next, so current node now points to node of 3. Is it null? No, right? So we print 3. Again it goes to the next, so it comes to node of 4 now, prints 4. Now we go to the next. Is current node null? Is null. Exit. Right, so let's implement this logic. We'll have a current node variable which will point to the head, And then while current node not equal to null, we'll do system.out.print current node dot get data current node is equal to current node dot get next. All right, so far so good. And then we do a blank line. Looks good. Let's write a main function and check if the code works. But before writing main function, let's take a look at what we have done so far. So we have our node class and linked list class, as we have discussed. In the node, we have a data component as well as a next link. We have housekeeping data around it. Then we have the push function implementation for linked list, which is if the current head is null, I mean the linked list does not have anything, we make the first node as head and assign data to it, and the next has null. And if it has data, we traverse to the end because we are implementing push. And that's how for print list as well, the same logic. We just check if current node is not null, we print it and move to next, and so on. If you take a deeper look and if you're able to understand it, this data structure can be easily modified using recursion as well, because you see the same kind of properties in like node next, node next, node next. You can just recur and do things. Maybe we can have few videos on how to solve these, do these things using recursion as well, right? So let's make a linked list of my list equal to new linked list, right? My list dot push 1, let's copy this, 2 10 5, insert something else, 6, my list dot print list, right? Let's run it. Moment of truth. It says 1 2 1 0 5 6. I think we did not give a space in the print function. Yeah, so we should give a space here as well. Now let's run it again. 1 2 10 5 6, just in the order we inserted, right? So this is how the implementation in Java looks like. So I hope you understood the concept of linked list. I hope the basic idea is clear to you guys now, because from next video onwards we are slowly going to start solving from easy to medium to hard problems. So take your time, understand these concepts. This is not difficult at all. This is just building blocks of data structures. So, and if you don't understand it, don't worry, just try to practice. The key to learning these data structures is not even learning, to understanding these data structures is visualizing. Even when I was in first year, I struggled a lot understanding these things, and I used to try to learn how these things happen. But no, once you just try to visualize things, it becomes so easy for you. So I hope with this said, you will try to visualize it. You'll try to just do it again and again and try to visualize it. So with this, take care. We'll meet again in the next video. So for today, that's it. Merry Christmas. Have fun. Thanks a lot for watching. Stay tuned. And if you really like this video, please subscribe it. Please subscribe to the channel and give this video a thumbs up. Thanks.